Hello everyone, this is our second video, the continuation of firms' decision making. In the previous lecture, we used a numerical example to show how we depict a firm's production functions and cost functions, how production usually looks like for a firm. By understanding cost curves and cost functions, we would be able to talk about profit-making decision, right? Because remember the definition of economic profit. In this course, we assume firms try to maximize their economic profit. And the definition of economic profit is total revenue minus total cost, total economic cost, right? So in order to decide how many output to produce, a firm should know its cost functions. And cost functions, as we have seen before, depend on production functions of the firm. So in this hour, we will draw the production curves and cost curves, and we will talk a little bit more about the relationship between two. If you have difficulty in following any part of this lecture, I suggest you go back to the previous video first and then come back here. So let's start with production curves or production functions. We are talking about production curves and cost curves in the short run. Remember, we said that firms make their decisions in two different time horizons, short run and long run. The definition of short run, this is the time period during which the firm has at least one fixed input, meaning there is an input whose quantity the firm is not able to change. It cannot increase the quantity of that input. It cannot get rid of that input in the short run. In the long run, we assume all inputs are variable. Now, in the short run, when we are showing production functions, we are actually depicting the relationship between the quantity of variable input and the amount of output. Okay? So we are basically asking the relationship between variable input and output. In our examples, in this course, for the sake of simplicity, we usually assume there are two factors of production, capital and labor, and we generally assume labor is the variable input. Capital is the fixed input. So in our production curve, this is how we draw it. Okay, on the horizontal axis, we have our variable input, labor. On the vertical axis, we have quantity. Okay, this is, for instance, if we are talking about a firm which produces sandwiches, this is the amount of sandwiches per labor. Okay. Now, first, we would like to show total product curve. Again, in the numerical example, we have already seen total product curves look like this. Okay. So I didn't draw a straight curve. This curve has a specific shape, right? Now you can see, although you cannot know the exact point, but somewhere around here, okay, at a certain amount of labor, the shape of the curve changes. It becomes more like this. And up to here, it is going like this, okay? So what is the meaning of this? In this segment, okay, in this part of the total product curve, when I increase labor, total output increases at an increasing rate. Okay? So, okay, this curve has a positive slope, meaning when I increase labor, output increases. That is the meaning of positive slope. But output increases at an increasing rate. Okay, so each additional labor adds to the output more. Now, after this point, in this segment of the total product curve, when I increase labor, output increases, yes, this also has a positive slope, but it increases at a decreasing rate. So the slope in this part is going down. The slope of total product curve in this part is going up. Now, just by looking at the graph, how do I know this? If you have taken basic calculus, right? If you draw straight lines that are tangent at different points, okay, I can draw tangential lines, and if I do it really nicely, right? If I draw different straight lines, you'll see those lines will get steeper and steeper, meaning the slope of this curve here is higher than the slope of this curve here. So the slope is increasing. Here, if we go to this part of the total product curve, you do the same. You draw straight curves that are tangent to this curve at different points. And you will see, look for instance here, the slope of this straight curve, this is flatter, so this is a smaller slope. It gets smaller, right? So this is how we interpret, how we read this graph. But what is the real life reason? Why do we think as economists, usually in the short run, total product curves look like this? What is the reason for that? We have already explained this, but before repeating that explanation, let me draw marginal product curve. Now, I have the same numbers here, right? So for marginal product curve as well, on the horizontal axis, we have labor, variable input. On the vertical axis, we have quantity. Now, marginal product, remember the definition of marginal product of labor. Marginal product of labor is the change in output in response to a change in labor. Right? So the change in output when I add one more labor. This is formally, this is by definition actually, is the derivative of total product. Right? Change in total product divided by change in labor. You can use quantity here, sorry, the letter Q here as well as total product if you wish, right? So marginal product is the derivative of total product, and marginal product curve usually, if you have a total product curve like this, okay, marginal product first increases. Why it is increasing? Because the slope here is increasing. And then after some point, it decreases. Okay? A usual standard marginal product curve has inverse U shape. It has a huge part where it is going down. It has a negative slope. Okay? Now, we have already explained the reason marginal product is increasing or the slope of total product is going up for a certain amount of labor is division of labor and specialization. We talked about this, so I'll not repeat it. But after we use a certain amount of labor, the increase in total product starts diminishing. Okay? Why? Because we have one fixed input. Because there is a fixed input and two inputs, in this case capital and labor, they are complementary. I'm keeping the number of ovens as constant and I'm employing more and more workers. Yes, they can produce more sandwiches, but since I'm in the short run and since there's only one oven, the amount they can add to total production will be going down. And eventually it can even be zero. If this becomes flat, marginal product will be zero. And here, if we draw that part, marginal product will be zero, right? So after a certain amount of labor, marginal product has to diminish. This happens always in the short run, whether sooner or later. Because this happens all the time, because this is such a common phenomena, we call it a law. So this is called the law of diminishing marginal returns. The law of diminishing marginal returns. That's why we see this. Now, we also talked about average product of labor. For a total product curve that looks like this, average product curve has an inverse U shape. And always the mathematical relationship between marginal product and average product requires that marginal product curve intersects average product at its maximum point, right? This is always true, and we showed why with an example in the previous video. So these are our production curves, okay? This is all you need to do, but one thing that is really crucial when we are drawing production curves or when we are talking about production functions, the relationship is between variable input and output. Variable input and output. Now, we use this relationship to draw cost curves, okay? If I know how many labor I need to use to produce a certain amount of output, and if I know the cost of this labor, how much does it cost me to hire one more worker, the wage, right? Then I can measure the cost. So the cost curve shows us the relationship, the cost functions shows us the relationship between the amount of output and the total cost we spend. It is a monetary value. So I will draw it here. Very, very important. On the horizontal axis, we will not have labor. The way we define cost functions, we define them with respect to the quantity. Okay? So for each quantity this firm produces, I'm asking myself, what is the cost of producing this thing, right? So if I only take into consideration, so remember, cost in the short run, total cost has two components. The cost of variable input and the cost of fixed input. So total cost is always equal to total variable cost plus total fixed cost. So on this graph, I would like to depict total variable cost. Okay? So total variable cost, because there is such a relationship, there is an amount of output that corresponds to this labor. Okay? Let's call it Q star. Okay? If I hire this many people, this can be 4 or 5, whatever it is, I produce a certain amount of output, 20 sandwiches, right? So here, what do I have here? Costs. Meaning, this has a monetary value, let's say 20 TL or $50. It should be expressed in terms of dollars or TL, right? So a total variable cost curve that corresponds to this total product curve will look like this. Okay. So this curve is coming from this one, right? What we see is not exactly the same. It is actually the opposite type of relationship. So if I draw such a curve, what you see, up until this amount of quantity, right, the costs are increasing. They are increasing, yes. This has a positive slope, but they are increasing at a decreasing rate. Okay, from up here, when we increase the amount we produce, the costs are increasing, but they are increasing at an increasing rate. Okay? Now, how do I know? Again, if you have taken basic calculus, you can show it very easily with drawing straight lines that are tangent to these curves. But let me do something else for those of you who have difficulty understanding. Now let's say I'm increasing quantity, the amount I produce by 1 here, okay? Look at the change in vertical axis. Okay? This is the increase in costs. This is how much costs would increase when I increase output by 1. Okay? Now let's come here. Let's say I have an amount of quantity here. For instance, this can be 10 to 11. This can be from 20 to 21. I want to keep this vertical distance the same. I'm increasing quantity only by 1 additional unit, right? Okay. I go from, so this is my 20th quantity. This is my 21st quantity. I go and look at the cost of each. Look, this is 20th quantity. This is the 21st cost. So what is the additional cost? Okay. Now, when I increase my output from 10 to 11, this is the increase in cost, which we will refer as marginal cost. When I increase quantity from 20 to 21, this is the increase in cost, which is the marginal cost. What happened? As we increase output, the increase in costs get larger. Okay? This is the meaning of this slope. Why it is getting larger? Why at this segment it is getting smaller? Marginal cost is getting smaller, but at this segment marginal cost is getting larger because of this relationship we described. So let me show it here with a separate graph. Here I have quantity. Whenever we talk about cost curves, we have quantity here, and here I have costs. But this time, I want to draw marginal cost curve. So like marginal product, marginal cost, by definition, marginal cost is the change in total cost in response to a change in output. I didn't say labor, I said output. So what happens to my total cost? Actually, to my variable cost, when I increase my output only 1 unit, right? That is, by definition, marginal cost is equal to change in total cost divided by change in quantity. You can write this as change in total product as well, okay? So this is the definition of marginal cost. So there is an amount of quantity that corresponds to this labor. So marginal cost first diminishes. Why it is diminishing? Because slope is going down here. And then it increases. marginal cost after a certain amount of quantity, it has to go up. And the reason for this is the law of diminishing returns. In the short run, when we add more labor, the quantity is increasing at a decreasing rate. Because of that, the cost increases at an increasing rate. Let me explain it in one more sentence, because this might be the most difficult to understand thing here. Here, I'm employing one more labor. Instead of 10, I have 11 workers. That additional labor, the labor itself, one more worker, costs me the same amount of money, because at least in this course and in most of our economic analysis in the introductory courses, for the firm, wage, the price of labor, or the price of capital, they are constant, they are given, okay? So if I'm paying an hourly wage of, let's say, 15 TL per worker, okay? As a firm, I cannot change it. I have to accept it. So for this worker, I'm paying 15 TL per hour. For this worker as well, I'm increasing, okay, here I don't have the workers, but if you go from this example, when I increase labor by 1, okay, at any point, this labor, it doesn't matter. Each labor, I have to pay the same amount of money, okay, because firms are price takers in the input markets. The wage is given. The price of capital is given. So I'm paying the same amount for all these labors. But look, this labor here, he adds to the output, let's say, 4 sandwiches, but this labor here adds only 1 sandwich. Marginal product is diminishing. This labor is less useful than this one, right? So I'm paying them the same amount of money, 15 TL, but I get only 4 sandwiches here. I'm paying 15 TL, I'm getting 1 sandwich here. So the cost of that 1 sandwich is higher. It cost me 15 TL. But for these 4 sandwiches, each sandwich cost me less because labor was producing more at the margin here. Because of this, marginal cost is increasing here, okay? So the reason marginal cost is upward sloping is exactly the same reason why marginal product is diminishing. And this is the most important thing. Now, there is one more thing about this graph. This is important. That would be really important later. For this marginal cost curve, okay, this is our total variable cost curve. I can also draw total cost curve. So remember the definition of total cost. Total cost is total variable cost plus total fixed cost. Total fixed cost is the cost of the fixed input, right? So when I want to show it on this graph, I will add to this number, whatever it is, the same amount, because capital cost me 10 TL, right? So I will draw another curve here. Okay, another curve here above the total variable cost with the exact shape, exact slope, but it is above because this vertical difference, there is a vertical difference here which is same everywhere. This vertical difference, because of the graph, it might look different to you, but they should be the same. This vertical difference is called total fixed cost, okay? So total cost is total variable cost plus total fixed cost. I can draw it like this. Now here I would like to draw 2 more curves, which we did with our numerical example. Average variable cost Okay. Average variable cost, U-shaped curve, and it intersects, this is always true because this is a mathematical relationship that comes from here. Marginal cost curve always intersects average variable cost curve at its minimum. Okay, this is the minimum point of average variable cost. Now I want to draw average total cost. Average total cost looks like this. Average total cost is above average variable cost curve because of the fixed cost. Now I will do something here. If you divide all these, both this part and this side, to quantity, okay, you will find average total cost is equal to average variable cost, this is average variable cost, plus average fixed cost. So these were the definition of average total cost, average variable cost, average fixed cost. So the vertical distance here between these two curves are called, it is called average fixed cost. And there is a reason I draw it like this. This is not by mistake. The distance gets smaller. The distance gets smaller because average fixed cost, let me use something else, because average fixed cost is a downward sloping curve, okay? It is not U-shaped, unlike average total cost and average variable cost. Average fixed cost, if I have to draw it, I want to do it somewhere else. Average fixed cost looks like this. Why? Average fixed cost is total fixed cost divided by quantity. This is a fixed number. It's constant. This is changing, but this is constant. So whatever the cost of capital is, fixed input, whatever the cost of plant size, right? Let's say 10,000 TL. I'm dividing that same number with a higher number, right? 10,000 divided by 1, 10,000 divided by 2, 10,000 divided by 3. So it gets smaller. There is no U shape. This is called average fixed cost. So average variable cost curve and average total cost curve are U-shaped. Marginal cost intersects both at their minimum. Okay. One more thing, a definition that we will use later. Now, if I ask you, now you know this firm, you know it is cost curves, you know this firm, and you have all the numerical information, okay? Tell me what is the output level that the firm chooses to produce. How many sandwiches will this firm produce? Can you answer by looking at this graph? Now, the correct answer, no. You cannot answer just by looking at the costs. Okay? You need more information. Why do you need more information? Because of this. Profit is defined as total revenue minus total cost. Okay? Now these curve, this curve gives you information about this. Okay? As you increase output, this will be going up. Okay? And there is a point here. Look. Average total cost is minimum. So for instance, let's say, let's call this QE. I'll explain why I call it QE. For instance, if I produce 30 sandwiches, okay, the average cost of producing each sandwich is the lowest. will you choose this amount to produce because you are minimizing your average total cost? No. Okay? This point, this quantity is known as productively efficient quantity. Okay? It is just, if I ask you, what is the amount of output that maximizes the efficiency of production? This is the answer. Okay? If this firm produces this amount, it is producing, it is output at the lowest possible cost. If you go here, if you produce more than that, come up. I didn't draw it very well, but this is U-shaped. So the cost of this output should be higher than this. It is higher than this. Or if you come here and produce less than this amount, look, the cost of this output is more than this minimum. So, okay, the definition of productive efficiency in this course is producing something at the lowest possible cost. And this is the quantity that allows the firm to produce at the lowest possible cost. That's good. But this is not necessarily, and we will see this later, this is not necessarily profit maximizing quantity for the firm. The firm doesn't, okay, it cares about costs, but it actually cares about profit. Okay? I'm a firm. I want to maximize this. Okay? So this is price times quantity. This is the definition of total revenue minus total cost. And total cost is a function of quantity. And here we also have quantity. So when I add when I produce as a firm one more output, it brings me more revenue, okay, because I'm selling it. But it brings me also more cost. It costs me more. More revenue, more cost. At each point, I have to compare that additional revenue to additional cost. What is the additional revenue? What is the marginal revenue? What is the marginal cost? So that is how I will make my profit maximizing decision, which we will see in the next lecture in detail. But here you should know this quantity is the productively efficient quantity. It is not necessarily profit maximizing quantity. Now, we would like to talk about, this is all I would like to say about short run, and then I'll talk about long run firms' decision making.